1.2, finding cube roots. Yesterday we kind of talked about square roots a little bit. How did I find a square root yesterday?
Find the number that's multiplied by itself.
Very good. Looking for the number multiplied by itself that gives me that number under the radical, correct?
Yes, sir.
AKA finding the number squared, that would give me that number under the radical. Does that make sense? So if I gave you the square root of 64, what would that be? 8, right? Because 8 times itself gives me that number, 64. 8 squared gives me 64. Does that make sense? What would be the square root of 25? 5, because 5 times itself gives me 25. 5 squared gives me 25. Are we okay with square roots? So what do you think, how do you think we would find a cube root? If a square root is finding a number times itself or a number squared that gives me that number, what do you think finding a number or the cube root of a number would entail? Now multiplied by 3, but I would have how many of that number being multiplied by itself? 3 of them, right? So a number cubed, that would give me that number. So a number times itself again. Does that make sense? Everyone okay with that? And if you notice right here, we have this radical, the square root. There's understood to be a 2 right here because we're dealing with a square root. I'm looking for a number squared that gives me that number under the radical. Okay? That's called the index of our radical. And the number under the radical is called a radicand. Okay? Whenever we're dealing with cube roots, what do you think that little number is going to be right there? 3. Does that make sense? But when we're dealing with a square root, that 2 is never written. It's just understood to be there. Okay? So, a cube root of a number is a number that, when multiplied by itself and then multiplied by itself again, so I got 3 of that number, right? All being multiplied, equals the given number. A perfect cube is a number that can be written as the cube of an integer. Here's our symbol that we use to represent a cube root. Like I said, it's just our radical with 3 in the index. Okay? So a perfect cube is just a number that we can take the cube root of and get a whole number. Okay? So on this previous slide, we would consider these numbers perfect squares. Because when I take the square root, I get a whole number. Take the square root, I get a whole number. So these two are perfect squares. Does that make sense? Okay. Are there any questions about what a cube root is or a perfect cube or anything like that? Can I move on, or are we still writing? You don't have to write this down necessarily. These are for your notes. These are just for you. Okay? But if someone wants to get them down, I'll let you write them down. We good? Okay. Find each cube root. So letter A, I want to find the cube root of 8. So I want to find the number that when it's multiplied by itself and multiplied by itself again gives me 8. So a number to the third power that gives me 8. So what number do you think that is?
2.
Okay, let's try it out. 2 times 2 gives me 4. Times 2 again gives me, there we go. Cube root of 8 is 2. We okay with that? Do we understand the concept behind a cube root? Okay, letter B. Cube root of negative 27. What number times itself again gives me negative 27? What number to the third power gives me negative 27? Negative 3. Let's try it out. What's negative 3 times negative 3? Positive 9, right? Positive 9 times negative 3. Negative 27. Does that work? Yes, it does. So negative 3 would be my cube root of negative 27. Uh-oh, here's our fractions. You guys love these fractions, don't you? Letter C, cube root of 1/64. Keep in mind, how do we multiply fractions? Straight across, right? Not cross multiplying. Just straight across. Numerators times numerators, denominators times denominators, correct? So I'm looking for some fraction that when I multiply it by itself and multiply it by itself again gives me 1 over 64. So what do you think the numerator of my fraction is going to be if my numerator under the radical is 1? 1, right? Because I'm going to have to multiply 1 times 1 times 1. That's going to give me 1, right? So in the bottom, I'm looking for a number multiplied by itself again, that gives me 64. What is it? 4, very good. So if I multiply 1/4 by itself and then by itself again, I should get 1/64. Let's try it out. 1/4 times 1/4 would give me what? 1 over, remember we're multiplying here, multiplying straight across. 1 times 1 is 1. 4 times 4 is 16. Got to multiply that by 1/4. 1 times 1, 1. 16 times 4, 64. Does that work? Yes, it does. There's my cube root. Fractions aren't that bad, are they? Sometimes y'all see fractions and just freak out and don't even want to attempt the problem. Okay? Sometimes, though, it's a lot easier than what you're expecting it to be. Okay? Okay, so do your best. You guys can do it. You guys can handle fractions. Okay? Last one here on this slide. Cube root of 27 over 125. So what we can really do here, I don't know if you noticed this on letter C, I tried to hint at it, but essentially we can just take the cube root of our numerator, and then we can take the cube root of our denominator, and that'll give us our fraction, right? Because I'm just multiplying straight across. Does that make sense? So, for right now, I can just deal with the numerator and find the cube root of 27. So what number times itself gives me 27? 3. 3 times 3 is 9. 9 times 3 is 27. And then now I can look at the denominator. What number times itself again gives me 125. We already said it. 5. Yep. And that works again because we're multiplying straight across. 3 times 3? 3 times 3? 3 times 3? What is 3 times 3? 9. There we go. Thank you. 5 times 5? 25. And then multiplying that by 3/5 again. We said 9 times 3 was 27. 25 times 5? 125. So I know 3/5 checks out. Okay, is that making sense for these 4 examples? We all understanding it? You good? Okay, moving on. Evaluate each expression. Okay. So now, we've kind of expanded the problem a little bit. It wants me to evaluate this whole expression. What we did yesterday is going to come into play here using our order of operations. Okay? So we're just using our order of operations to simplify this. We can do this because yesterday we had some square roots within our expressions, right? We handled those just fine. Same concept, we just have cube roots instead of square roots. Okay? So letter A. 2 times the cube root of negative 216 minus 3. So, grouping symbols. Do I have any grouping symbols? Not technically, but what should I probably simplify first here? Yeah, the cube root of negative 216, right? Because I've got something being multiplied by that. I've got to figure out what that number is before I can multiply it by 2, right? So, what number times itself again gives me negative 216? What is it?
It's not 7, is it?
No. Start typing in numbers in your calculator. A number times itself again. Negative 6. Negative 6 times negative 6 is? Positive 36. Positive 36 times negative 6 would give me negative 216. So the cube root of negative 216 is negative 6. Notice the rest of my expression stayed the same. I've got that 2 being multiplied by it, the 3 being subtracted from it. So I don't have any more grouping symbols with any operations going inside of them, do I? No. Do I have any exponents? No. So I can skip the E part of GEMDAS. Do I have any multiplication or division? Yes, I do. So I need to do all of that first from left to right. Remember, I'm lumping multiplication and division together. Do it all from left to right. So what's 2 times negative 6? Negative 12. Any more multiplication or division? No. Do I have any addition or subtraction? Yeah, so what's negative 12 minus 3? Negative 15. I have no more operations, so negative 15 is my answer. Questions on that? How are you feeling about cube roots? Good? Okay? Are you kind of at least in the thumbs up, thumbs to the side range? Is there anyone that's thumbs down for right now? Yeah, I can understand that. Okay, letter B. I've got the cube root of 125 to the third power plus 21. So, order of operations here. Do I have any grouping symbols? Yes. Yeah, I do. Probably need to evaluate that cube root of 125 inside that set of parentheses. Okay? So what number times itself again would give me 125? 5. Very good. So this is saying whatever number I get for the cube root of 125, it wants me to cube it. So I'm going to leave that 5 in the parentheses, raised to the third power. Do I have any more operations going on inside my grouping symbols? No. So I'm done with G. Am I moving too fast for anybody? Okay. Do I have any exponents? Yes, I do. Got that 5 to the third power. So what is 5 to the third power? Or 5 times 5 times 5, because that's what it's telling me to do, right? 125. What do you notice just happened?
It just went back.
I went back to the number I had under the radical, correct? Notice I've got a cube root raised to the third power. Those two things cancel each other out, okay? If I have a cube root raised to the third power, I'm just going to be left with the number under the radical, okay? Same thing's going to happen if I square a square root. If I have the square root of 16 squared, I would get what? 16. If I have the fourth root of 725 raised to the fourth power, what am I going to get? 725. Those two numbers do have to match in order for this to work, the index and my exponent. Okay? If those are two different numbers, I've got to do the steps that I just took. Okay? Because it's not going to give me just the number under the radical anymore. But if these numbers match up, those things are going to cancel each other out. I'm going to be left with the number under the radical. So keep that in mind, just in case there's problems like that on the assignment. I'd be okay if you just went straight from here to here. So you get to skip a step, essentially. Okay? Any questions on that? Okay. Do I have any multiplication or division? No. Do I have any addition or subtraction? Yeah, what's 125 plus 21?
146.
146. Questions on B? How are we feeling? Pretty good? Not too shabby? Can I move on? All right. Let's combine yesterday and today. Evaluate each algebraic expression for the given value of the variable. This is what we did yesterday, right? He gave us an expression. He gave us a value for a variable. and we had to plug that number in and then evaluate the expression. I'm doing that again today, but it's going to involve our cube roots. Okay? So letter A, I've got x over 4 plus the cube root of 192 over 3. So what do I need to do here on letter A?
Figure out what 192 over 3 cubes is.
Well, before I do that, I need to do what?
Put in the x.
Yeah, substitute my value of x into this, the expression. So anywhere I see an x in the expression, it's getting replaced with what? 192. Everyone okay with that? Questions there? Okay. Yeah, we probably need to figure out the cube root of 192 over 3 first, right? So let's try to do what we did earlier and find the cube root of them individually. What's the cube root of 192? Can you find a number that's going to be a nice whole number that when I multiply it by itself again, it's going to give me 192? No. You're not going to be able to do that for 3 either. Does anyone have any ideas what I might have to do here first? Simplify what?
192 over 3.
Very good. Yeah. That fraction is just division, correct? So in your calculators, type in 192 divided by 3, and what do you get? 64. So this just becomes the cube root of 64. Does that make sense?
Oh, okay.
Now, I could probably figure out what the cube root of 64 is. So what number times itself again gives me 64? 4. We're talking about cube roots, not square roots.
Oh, we're just 3?
Mm-hmm. That's what that little 3 and that little nook of that radical means. Looking for a number, times itself again, that gives me that number under the radical. Okay? Any questions on what I've done so far? Okay. Do I have any grouping symbols?
No.
Do I have any exponents?
No.
Do I have any multiplication or division? Yes, I do. I've got 192 divided by 4. What does that give me? 48. Do I have any other multiplication or division?
No.
I do not. Do I have any addition or subtraction?
Yes.
Yes, I do. 48 plus 4 gives me 52. Any more operations?
No.
Nope. There's my answer. Questions on A? You okay with that? All right. Let's move to letter B. More fractions. Love these fractions. Well, how do I need to start letter B? Fill in for x. What am I replacing all my x's with? 127th. So I get 9 times 127th plus the cube root of 1 over 27. I know we were good with this yesterday, but are we still good plugging in a number for a variable?
Yes.
Whether that be a fraction or a whole number. Okay? That's what it told me x equals, so I've got to use that value for x in my expression. All right. What do I need to do first here?
Find the square, the cube root of 127.
Find the cube root of 127. So let's try to do what we did earlier and find the cube root of my numerator and then find the cube root of my denominator. So, what would be the cube root of 1? What number times itself again gives me 1? 1. Now we can look at our denominator. Find the cube root of 27. What number times itself again gives me 27? 3. So the cube root of 1 over 27, 1 over 3. You okay with that? Okay. Do I have any grouping symbols with operations going on inside of them? No.
Yes. No.
Well, technically I do. I do have this grouping symbols with division going on inside, but can I simplify that any further?
No.
No. So I can go ahead and skip my grouping symbols. Do I have any exponents? Nope, so I can skip the E. Do I have any multiplication or division?
Yes.
Yeah, I've got 9 times 1/27. Any idea what that's going to give me?
27.
Huh?
27.
9/27, but what would that reduce down to?
1/3.
1/3. Everyone okay with that? Remember multiplying fractions, we multiply straight across. 9 times 1 gives me the 9 up top. 1 times 27 gives me the 27 down below. 9 and 27 are both divisible by what number?
3.
Well, a bigger number than that.
9.
9. 9 divided by 9 gives me 1. 27 divided by 9 gives me. That's how we got 1/3 right here if you got confused there. Any confusion? Do I need to write that out? Are we okay with that? Or, if you type in 9 times 1/27 into your calculator, it's going to spit out 1/3 for you. Okay? Any questions there? Any other multiplication or division?
No.
Nope.
No. Well,
Any addition or subtraction?
yes.
Yeah. Let me ask you this. Without using a calculator, let's add these two fractions. What do I need in order to add or subtract fractions? Common denominator, right? My denominators need to be the same. Are they the same here? Yeah, they are. So I don't have to change my denominators at all. If they're the same, what can I do with the two numerators? Add them. What's 1 plus 1? 2. And then what do I do with my denominators? I add them. What do I do with them? Keep it the same, right? So I get 2/3 here. Any questions on B? Still feeling okay? You guys love fractions? They're not too bad to handle, are they? Not terribly bad. Can I move on? This is my last example here. Evaluate 5 times the cube root of 3x minus 9 minus 7x when x equals -6. 5 times the cube root of 3x minus 9 minus 7x when x equals -6. So the very first thing I need to do. Plug in for x. What am I plugging in for x? -6. Anywhere in my expression that I see in x, I replace it with -6. Be careful here that -7 times -6 is not under my radical. So I cannot put it under my radical. Okay? The only things that are under the radical are the 3 times -6 minus 9. Okay? All right. Let's go through our order of operations. Do you have any grouping symbols? Yeah, I'm going to consider my cube root a grouping symbol, especially if it's got a lot of operations going on underneath it. Okay? So let's simplify everything that's under my radical using our order of operations. So once again, we're using our order of operations within our order of operations. Okay? So what would come first under the radical? How'd you do that?
Multiplication.
Yeah, multiplication, right? 3 times -6, which we said would be -18. Okay with that? Is the stuff under the radical completely simplified now? Or do I have more operations under the radical? Got more operations. What's -18 minus 9? What? There you go. -27. And while we're at it, let's go ahead and simplify our cube root. What number times itself again gives me negative 27? Negative 3. Everyone okay with what I've done so far? All we did was simplify the inside of the radical and then take the cube root. Okay? So, we've simplified our grouping symbols. Do we have any exponents? No. Do we have any multiplication or division? Yeah, so we're going to do that from left to right. What's 5 times negative 3? Negative 15. Negative 7 times negative 6. Positive 42. Any questions up to this point? Am I moving too fast for anybody? I can slow down if I need to. Do I have any more multiplication or division? Nope. Do I have any addition or subtraction? Yes, I do. Negative 15 plus 42 would give me what? 27. No more operations, so I'm done. Questions on this last example? Give me a thumbs down, a thumbs up, a thumbs down, or a thumbs to the side, depending on how you feel about this. Okay? Make sure, as we're working on the assignment in class, that you ask questions if you have them. Okay? Now would be a great time to clarify anything that you're not understanding. Okay? Here's our assignment. Page 13, numbers 2 through 26 all. This will be due Monday, August 22nd. Monday, August 22nd. Are there any questions about my notes before I end my recording?